Shake Table Lab by Finn Warren, Gavin Hatch, and Kyle Lundberg. Before we could start building, we had to create a building sketch. The purpose of the building sketch is to give us something to follow instead of just winging the project. The total height of our building in the sketch is 36 centimeters. The height is split up equally between 2 floors. To start off, we had to create a good foundation because all of the pressure that the building has will be put upon the foundation. My partners and I were careful on measurements, positioning, etc. because we knew that the way to succeed was with a good foundation. After we thought our foundation would be successful, we followed our construction plans and created support beams for our sides. We chose to do different designs for our top and bottom support beams because we wanted to save straws to work more on the base. Once our side support beams were stable, we worked on making support beams in the middle. The reason we were doing this is because we want to equalize the weight so each straw takes an equal amount of pressure. My team decided to add a little extra support on our top level side beams. We did this because we thought that if the 2 straws cave in, it will snap. To prevent that from happening, we added support for our support beams. This construction sketch shows all of our measurements for the building. The arrows pointing to the pink part are referring to how long the floor is. The average length of the floors are 18 centimeters and the total floor height is 37.2 centimeters. Our building didn't seem to be affected by the weights we put on it. The reason for this is because we made sure that the weight was distributed evenly among the straws. Even though I said we distributed the weight evenly, we had to put the most weight on our strongest parts because they have the most support. The strongest parts have 3 straws and lots of tape because the 3 straws will have the most stability and the tape will hold it together. I think the strongest part was the middle of our structure because it was strengthened by the most straws. My group and I thought that the center of the structure appeared to be the most stable. It is my thought that the weakest part is the triangular structure on the 2nd floor. The reason for this is because it might bend when weight is forced upon it. My group and I made sure we only put tape on places that were necessary. We did this to strengthen our support for the building. When our group put on the paper for the floors, we made sure that it wasn't flabby or sagging. Our explanation for this is that if it were to be sagging, this may cause an effect when we put the weights on our building. The effect would be the weight sinking through the floor, causing the paper to snap, and potentially bending or breaking the straws. In this video, we currently have 14 sandbags.
We have to get 2 more to feed. Yeah. Die. Yes! It's gonna die, guys!
In this video, our building is holding 18 sandbags. Sadly, this is the video showing our building fail.
Where would we have got the extra shirt?
When my group was testing our building, we had an app that would tell us how much the building bounces, sways, etc. The x-axis is the movement from side to side, y is how much our building moves forward and backwards, and z tells us how much the building was bouncing.
Our tower was able to hold a successful 18 sandbags. We are very proud of this because this was the most amount in our class. Our building failed in the bottom left front corner. We are very upset about this because we should have added more tape. If I were to do this again, I would add more tape to the bottom because that's where our tower went wrong. We did not have it stable enough so that it broke and snapped in half. I learned that it's really hard to make a building that is earthquake proof because buildings have to be very stable to survive an earthquake. Earthquakes are very powerful and can knock down buildings, so you have to have a great structural design to make it last. I really liked working with my group throughout the process. They are very great team workers and they contributed a lot to the process. I also liked the scientific part, which was making a tower and testing it on an earthquake. I learned a lot about earthquakes in this process.
My group's building held 18 sandbags. We thought of this as an achievement because it was the greatest amount in our class. When I watched my tower, I saw that it failed at the bottom left corner where there are 3 straws. I think it failed because when it was swaying side to side, the force made the straws crack or snap. I would have added extra straws to support the sides since that is what made our tower fail. I learned that in order to make a good building, you need to make sure everything is secure before you can say you are finished. I enjoyed that we got to work with our friends while making a science experiment. I also thought that this was a fun project to test out our building skills.
My group is very proud because our building held 18 sandbags. That is the most in our class. Our building failed in the bottom left corner because we did not add enough tape. The changes that we could have made to make our tower stronger is to add more cross beams and to make sure that tape was secure. Things that I learned about making an earthquake-proof building is that it is very hard because the earthquakes are very strong. The things I enjoyed about this lab would be working with my friends in building the structure.